Okay, our project is the recovery of high-value elements in Grinding Swarf. Grinding Swarf, as you can see over here, the company we're working with, L.E. Jones, takes these valve seat inserts for piston heads and grinds them down, machines them, so they're actually ready to be put in. What we're dealing with is the Grinding Swarf, the actual shavings from the piston heads. So we are looking at the different material properties of the swarf, hardness, density, magnetic strength, and we're trying to determine what the most feasible way would be to separate this. There's the physical way and there's the chemical way. We opted for the physical way; it's less expensive, more feasible. So we decided to focus on magnetic separation and particle size separation. So during the magnetic separation process, we use the Davis tube separator, which has different oscillating speeds to kind of shake the swarf down into pick up the particles, and different voltages. We focused on a number of different voltages, the main being 40 and 60 volts. After using this and changing up the oscillating speeds, trying different combinations, we found that we didn't have any effective magnetic separation based on the magnetic properties of the elements. As you can see, there's a lot of iron in here. We're trying to get off the nickel and cobalt, which are the two highest value elements, but we can't because there's so much iron in there. So we opted to go with maybe the size separation. In the sieving process, we use a number of different sieves based on the particle sizes. And it's a shaving process, so there's a number of different, there's tons and tons of different size particles and orientations. But we use from 28 millimeters all the way down to 53 millimeters, 0.53 millimeters, sorry. And we found that once again there was no effective separation. This we found probably was due to the fact that there are tons of different size orientations and particle sizes in there. And I guess we concluded that technically using the process that we used, we couldn't effectively separate it. But if you were to possibly go back and maybe make the particle sizes more, I guess, ergonomical, more uniform, you could maybe try another physical separation. But until then, we're going to have to say that no effective separation was concluded, and possibly try some sort of chemical separation like hydrometallurgy.